Now since we have understood, let's try to solve few more problems and understand that how do we go and find the time complexity. Let's take a very simple example here. Again, before I go and do that, let's quickly revise what is the definition of the time complexity. Definition of the time complexity is how the number of operations is proportional to the input size. Every problem that we have at hand and we have to find the time complexity, we always have to identify two things, that what is the number of operations and what is the input size, and if we find the proportionality, I'll be able to solve it. In this question, what is the input size? This is the input size. And number of operation is equals to number of times loop runs, right? So what I see here, if n value is equals to 1, how many times this loop will run? This will loop one times. If n is equals to 2, how many times the loop will run? It will run 2. If n is equals to 3, how many times the loop will run? It will be 3. So my operations, my number of operations, if you see here, is proportional to n, which is the input size. N is 1, number of operation is 1. N is 10, number of operation is 10. N is 1 million, the number of operation is 1 million. So here my time complexity will be what? Order of n. This is also called as big O n. Now what is big O? We'll talk about it a little later, but as of now, this is how you go and find the time complexity. Let's see a few more examples. In this case, again, I have to find the input size, so this is my input. And my number of operation is equals to how many times? How many times loop runs? It means that how many times this is printed, right? So as I can see here, this outer for loop will run 1 to n, so it will run for n times. And for each outer for loop, this is also will run for n times only, right? So the first time this inner for loop runs how much? N times. Then again outer for loop n times, then n times, and this goes till. So total number of operations will be proportional to n square. So time complexity becomes what? Time complexity is a big O of n square. Very simple. I have two loops, first runs for n times, second runs for the n times. So total time complexity will be equals to the order of n square. Fair enough? Great. Now let's try to move further. In this question, my input size is this. This is my input size. Now let's try to solve this problem again here. So here I have an input size n, and then if I have to find, no, this is the input size. Time complexity is what? Time complexity is how the number of operations is proportional to the input size. So in this case, what is my number of operation? The number of operations, how effectively these number of times loop will run, or I can say the number of times console.log is printed. Just to do this, one more thing, that if you see here, that these are all the nested loops, right? So this outer one runs for n times, this one runs for another n times, and this one again runs for how much time? This again runs for the n times, right? So there is a nested loop. Outer runs for n time, this runs for n time, and this another runs for n time. Effectively, how many times the console.log ijk will be print, executed, or how many times the loop will run? It will be equals to number of operations will be proportional to the n cube. All of these get multiplied. So effectively my time complexity will be what? How the number of operation is proportional to the input size. So time complexity will go of n cube. Now one important concept that I would like to go and add here, right? So whenever we have to go and find the time complexity, right? Let's say that I have a loop 1, and inside this I have a loop 2, and inside this I have a loop 3, and inside that I have a loop 4. Whenever we have this nested structure, right, whenever we have a nested loop, right, and let's say that this has a time complexity of, let's say this runs for n1 time, this runs for n2 time, this loop 3 runs for n3 times, and this loop 4 runs for n4 times. So effectively total number of operations will be equals to how many times? It will be equals to n1 into n2 into n3 into n4. This is how the total number of operations will look like, right? So whenever you have a nested things, the number of operations gets multiplied. Fair enough. So this is the number of operations that we will use for finding the time complexity. On the other hand, if that is not the case, let's say that I have loop 1, and then below this I have the loop 2, and then I have loop 3, and then I have loop 4, and let's say that this runs for n1 time, this runs for n2 time, this runs for n3 time, and this runs for the n4 times. For this, if I want to go and estimate the total number of operations for finding the time complexity, total number of operations should be equals to the max of n1, n2, n3, and n4, and this will be used for finding the time complexity. What I mean by this, let's take an example again. Let's say that if I have let's say that I have a code of piece which looks something like this. For I equals to 0, I is less than n, I plus plus, and then I have for I is equals j is equals to 0, j is less than n, j plus plus, and then I have something called as for k equals to 0, k is less than n, and k plus plus, and then you write here console dot log hello, right? This is one piece of the code, and the another piece of the code is like this. For I equals to 0, I is less than n, I plus plus, and then you have console dot log hello, and then again repeat the same thing for j equals to 0, j is less than n, j plus plus, and you write console dot log hello, and then you go and write for k equals to 0, k is less than n, k plus plus, and I go and write console dot log hello again. Now if you see here, since these are one below the another, the number of operations here and here, if I have to go and calculate here, the number of operations will be proportional to how much this runs for n times, this again runs for n times, this again run for the n times. These all are the nested loops, so it will be n cube. So the time complexity will be order of n cube. Whereas here this runs for n times, this runs for n times, this runs for n times, but all of them are one after the another. So the number of operations is proportional to n itself. So the time complexity will be equals to order of, and the time complexity here will be of the order of n itself. The time complexity will be order of n itself, right? So this is how. Another important concept when you're trying to find the time complexity, when it is a nested loop, when one after the other, this is the logic that you go and apply. Now let's try to see the another problem that we have at the hand. Let's try to find the time complexity of this problem statement, right? You can take a pause the video, try to solve it yourself and then give it a try. So again, every time you have to find a time complexity, we have to, again I'm repeating the definition of time complexity, you have to find the number of operations to the input size. Now here in this case, this is my input size and number of operation is how many times this? Number of operations will be equals to how many times this while loop runs, right? So now let's try to find that the total number of times this while loop runs. I don't know how many times it has run for the first time. So let's assume that number of operation is, let's assume that it will run for the k times. Okay. So the first time when the while loop is running, at that time the value of the first time when it is running, its value is equals to n. Second time when it is running, the value has become equals to n by 2. The third time when it is running, the value has become equals to n by 4, which is 2 to the power 2, right? I can go and write it as n into 2 to the power minus 1. This I can go and write n into 3 to the power minus 2, right? Or you just keep it simple, you just write it like this itself. Like this, if I go and run it for the fourth time, its value will get reduced to 2 to the power 3, right? Like this. So like this, if I go and assume that this entire while loop runs for k times, right? If I go and say that entire runs for the k time, then it becomes equals to n 2 to the power k minus 1, as you can see here. When it is 2, then it is 1. When it is 3, then 2. When it is 4, then it is 3. When it is k, then it is k minus 1. So these many times the while loop runs. So k plus 1th time, this k time the while loop runs, right? So k plus 1th time, if I go and talk about, this becomes equals to n by 2 to the power k. And this is the point k plus 1th time, and the while loop will break. So at this point k plus 1th time, n divided by 2k becomes approximately equals to 1, or I can go say that 2 to the power k become proportional to the n. Now it's 2 to the power k proportional to the n. So what I can do this, it's 2 to the power k is proportional to the n. I can take log base to both side. So when I go and do this, this becomes log 2 proportional to the log base to n. This value is k, so this becomes equals to k. K becomes proportional to the log n base to. What is my k? K is my number of operation. This is my number of operation. This is my number of operations. This is my input size. So now my number of operation is proportional to logarithmic n. So the time complexity of this question will be order of log of n. Now this is one good question that I want you guys to sink in inside your brain. If you are not been able to follow it, just pause the video, take it back. This is the advantage of studying from YouTube, right? You can go it back, watch this and tag me and let me know that you have understood this logarithmic. I don't want you guys to mug up anything that we go and master in the data structures and algorithm lessons. I don't want a single concept that you have to mug up. I want you people to apply the brain, understand everything logically and then go and solve it. No need of mugging even a single piece of thing. Fair enough? So this is the question. Now let's try to move to the next question. I have this function called as a print factors. Okay, and this is the input n. I equals to 1, I square, da 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 da. So again, this is my input size. And before deeping further into, what I have to do is that If I have to go and solve this problem, I have to find that how many times this execute. I have to find the number of operations. How many times this for loop executes is will be my the time complexity. Now I have to see here something, right? Every time I is getting incremented by 1, but it is running till this condition. So can you tell me, will it run for n times? No, it will not run for n times because I am comparing square of I square with n, right? So definitely it will not run n times, it will definitely run less than n times. So any times when you are not very sure of that how many times the operation will happen, you assume, take a number, let's say that it will run for k times. And ultimately what I have to go and find the k in terms of n. So here if I try to see that, let's assume that, let's say the first time when the loop is running, what is the value of I? The value of I is equals to 1. Second time when the loop is running, the value of I becomes equals to what? 2. Third time when the loop is running, the value of I becomes equals to what? 3. And I have assumed that it runs for how many times? K times. So at that time the value of I will be what? K. At that time, let's say that if it runs for the k time, this is all fine. At k plus 1th time, the value of I becomes equals to k plus 1, and at this time the loop breaks. So if the loop breaks at this moment of time, what this condition will be holding false. So what will happen? I square will become proportional to n that time, and at that time what is the value of I? I value is equal to k plus 1 whole square is proportional to n. Now what I do? I take a square root of this, so I go and say that k plus 1 is proportional to the square root of n. Now for higher values of n, this constant value I can go and ignore, so I can go and say that k is proportional to the square root of n, where k is my number of operations, n is my input size. K is number of operation, n is input size. What was the time complexity? The time complexity becomes equals to order of root n. So the time complexity of this problem will be order of root n. So every problem that you go and solve could be solved mathematically. The only thing that you have to do is that you have to understand the meaning. The time complexity is that how your number of operation is proportional to the input size. Am I clear, sir? Does it make sense? Fair enough. Let's move to the next question. Let's move to the next problem and see how we can solve it. Okay. So again, this is my input size. You can pause the video and try to solve this problem before I do it. And number of operation is how many times the loop runs. Number of times loop runs. And number of times the loop runs, the console.log one will be printed, right? I don't know how many times it is going to run. So let me assume that it runs for k times. Fair? First time when the loop runs, the value of the inputs it's equals to n. Second time when the loop runs, this becomes equals to square root of n, which means that it becomes n 1 to the power 2. The third time when the loop runs, this becomes equals to n 1 by 2 to the power 1 by 2, right? So this becomes equals to n 1 2 to the power 2. When the fourth time it runs, that becomes equals to n 1 2 to the power 2 1 2, that equals to n 1 upon 2 to the power 3. If you can see here, this thing I can go and write it as n n 1 2 to the power 1, right? So if you can see here, this is 2, then this is 2 minus 1, this is 3, then this is 2, this is 4, then this is 3. So similarly, if it runs for, say for example, k times, then this becomes equals to n 1 2 to the power k minus 1, right? So if this runs for k times, the value of n that time becomes n 1 2 to the power k minus 1. So I have this n 1 to the power 2k, okay, the kth term, fair enough. So this kth term which you have, at this point this while loop condition will break, right? So I can go and write it as n 1 2 to the power k is approximately equals to 1. At this point of time I can take log base to both sides. So when I go and take log both the side, this becomes log base to n to the power 1 2 to the power k approximately equals to log 2 base 1, right? Now this is a basic log, the maths that you would have learned in 9th and 10th. This becomes equals to log n, and here it becomes 2 to the power k, and this log 1 value becomes equals to 0. So this I can go and write it as now 2 to the power k is approximately equals to log of n. See, time complexity is all about approximation. We are trying to find at the very large values of n. Again 2 to the power k is approximately equals to log n. Since I have to take out the k, I take the log both sides. So this becomes log base 2 2 to the power k approximately equals to log of log n, right? This could be written as k is proportional to log of log n. Now since k is what? K is my number of operations, n is my input size. So the time complexity becomes what? The time complexity of this function equals to order of log n. I'm again telling you people, if you have not understood it well, everything is written here. Please pause the video here. This is a video which I'm trying to put. I don't want to scratch the surface like other YouTubers. I want to go deep, explain you everything in detail for which is needed for you to master the skills, right? So we have to go inside and solve it. Pause the video, solve it yourself. Only when you're able to do it, move on. Let's take another problem here. In this problem, what I see, I have two loops, right? This loop, if I go and see, I can see that it will work for n times, right? Because I starts from 1, I is incremented by 1 every time, and I value is less than equals to n. So this loop, when it comes outer for loop, will always run n times. This inner for loop which you see here, j starts from the I, j is less than equals to n, and every time j is getting multiplied by 2. So every time when something is getting twice, we have already seen in our previous problem, this will run for logarithmic n. If you are not able to understand why it is running for logarithmic n, go back, watch that portion, and then you should be able to identify that why I am saying that this for loop will run for logarithmic n. Don't stop it here, don't get demotivated. It's okay, for the first time you are learning it. Go back, watch some minutes back where I talked about when everything gets multiplied, the logarithmic value is log of n, right? If I want to see me, let me go and show you here. Let's say that if I have something called as for I is equals to 1, I is less than n, and I is equals to I into 2. And let's say that I have written here console.log hello. I want to know how many times this loop will run, right, or time complexity of this. I don't know how many times it runs, so I assume that the number of time it runs is k. K is the number of operations, and number of operations is nothing but number of times this loop will run. Fair enough. So let's say that first time when the loop is running, the value of I is equals to 1. Second time when the loop is running, the value of I has become equals to 2. Third time when the loop is running, the value of I has become equals to 2 to the power 2. Fourth time when the loop is running, it's becoming 2 to the power 3, right? If you see, if it is 3, then it is 2. If it is 4, it is 3. So if it runs for k times, the value of I will become equals to 2 to the power k minus 1. This many times the loop is running, right? Let's say that if the loop runs for k time, at the k plus 1th time, the value of I would become equals to 2 to the power k, and at this time the loop terminates. So the loop terminates at this time. The value of I is what? 2 to the power k. It means that 2 to the power k is approximately equals to n at the time the loop terminates. I take the log 2 both the sides. So I go and take log base 2, 2 to the power k, proportional log base 2, n. This gives me k is proportional to the log n, where n is my input size. K is my operations, right? Did you get it? So if I go back here, this will run for log n times, this is running for n times. So eventually, overall, if I go and say how many times the for loop will run, total number of operations will be proportional to n times log of n. So what will be the time complexity? Time complexity will be big O of n log n. The time complexity will be order of n log n. Am I clear? Make sense? This will be the time complexity of this problem. Let's move on to the next problem. In this case, again I see there are two loops. First, I starts from 1, I is less than equal to an I plus plus. So this will run for n times. If I go and look here, j equals to 1, j plus plus, and this is multiplying. This type of problem we have already solved. How many times this will run? This will run for the square root of n. So in totality, since one loop is inside another, number of operations where it will be equals to n root n. So the time complexity will be equals to order of n root n. The time complexity here will be the order of n root n. Am I clear? Make sense? Fair enough. Let's move to the another question here. If I see this one, I equal to 1, I square, this will run for square root of n times, and then this is just the conditional check. So total number of operations that I see here is proportional to square root of n. So time complexity will be order of square root of n. So the time complexity here is order of square root of n. Simple. Anytime you feel out, please go back, watch all the the concept that we have discussed, and then try to solve it accordingly. Let's try to move further. In this case, again I have multiple loops that I see here. The first loop I1, I is less than equal to an I plus plus. No doubt this will run for n times. Let's take another loop, j equals to 1, j is less than equal to n, and j plus plus. This again should run for n times. Third one, k equals to j, k less than equals to n, k is equals to, every time getting multiplied 2, so this will run for log n times. Since everyone is nested inside each other, so the total number of operations will be proportional to the n square log n. So what will be the time complexity? The total number of operation is n square log n, so time complexity will be equals to the order of n square log n. What will be the time complexity? Time complexity will be equals to the order of n square log n. So this will be my order of n square log n. This will be the time complexity. Let's move on further. If I go and take this question, this I equals to 1, I is less than equal to n, I plus plus, this will run for n times. This one, j is equals to 1, j less than 1, this will run for the n times. This k square, as you can see here, we have already solved this, will run for the root n times. So the number of operations here will be the number of operations here will be proportional to the n square root n. So my time complexity will come out as order of n square root n. This will be my time complexity of this specific problem. Let's move on further. So with this we have solved enough number of problems. Before I go and talk about this, let me go and talk about one more question, right? Let's say that I have a function called as print, and then I have a loop for I equals to 1, I is less than n, I plus plus, for j is equals to 1, j is less than n, j plus plus, and then I have break, then I have console dot log hello. Can you guys tell me what will be the time complexity of this? Just take a pause and put that into the comments. What is the time complexity of it? Now here if I go and see, this seems as if it will run for the n times. This if I go and see, this seems as if it will run for the n times. But actually this will not run for n times because there is a break statement. The break will ensure that every time it goes inside the for loop, it comes out of it. So eventually this runs effectively one time only. So here in spite I have two for loops, the number of operations is still equals to n into 1. So the time complexity will be still order of n only. So this will still have the time complexity of order of n itself. Am I clear? Does that mean? So with this we have solved enough problems. If you are able to solve all these problems, trust me, you have got a very good hold on time complexity. Always understand that every time you have to find the time complexity, you have to identify that how your number of operation is proportional to the input size. Going ahead, all the hundreds of the questions that we go and solve here, we'll make sure that every question that we solve, we first try to find the time complexity so that your practice keeps on going. Cool? Please put that into the comments and let me know that how comfortable you are now in finding the time complexity of any problem. Said that, there's a little theoretical concepts. When it comes about the time complexity, there's a three different types of the time complexity that we always talk around. Best case, average case and the worst case. Let me help you with the help of an example. Let's say that in a class I have multiple students standing in, right? So there are different students who are standing in, right? His name is Rahul, his name is Sohan, his name is Vishwa, his name is Shivani, and her name is Vaishali, let's say that. And let's say that I want to go and search for a guy called as, I'm looking for a guy called as a Rahul. Now when I go and start looking for it, I first went to the first person and asked his name, what is your name? And he said, hey, I'm Rahul. So I had a long list of the people that I have to go and check from, and the very first person that I go and check himself turned out to be Rahul. So I don't have to go and check any other person. This situation is called as the best case situation. So best case situation is the one in which you have to take a limited steps, and the very first thing that you do, you got the answer, right? So let's say that if a line of 100 students, the first student that I go and check, are you Rahul? And he appeared to be Rahul. This is the best case scenario. Now let's talk about the worst case. Let's say that I'm trying to look for someone called as a Vaishali. So in the worst case, what happened? I'll go to the Rahul and say, hey, what's your name? Rahul. No. I go to the next person. No. I go to the next person. No. I go to the next person. Finally, when I go and reach the last person, then I get to know the Vaishali is present. So this is the case where I go and iterate over all the possibilities, and only in the end I get the solution. Typically this will be called as the worst case. Then what will the average case? Let's say that we do this experiment 100 times. Sometime we find it in the beginning, sometime we find it in the end. So on an average we say that if I go and repeat this experiment for multiple times, I will be able to find somewhere in the middle, right? After 4 or 5 efforts, I'll be able to know where that person is. So in the world of the computer science, whenever you have to solve a problem, sometime you'll fall with best case, sometime you'll fall with average, sometime you'll fall with the worst case. But for you software engineers, for you programmers, for you who develop application, what do you think is more important to you among all these things? Whenever you write code, do you write the code for the best of the situation, or you write code for the worst of the situation? And the answer is we always prepare ourselves for the worst case. When we write the program, we always make sure that even in the worst case of the situation, my code still works. So out of all these things, I know that the time complexity has 3 different definitions: best case, average case and the worst case. But for me, the most relevant among all these will be the worst case time complexity. So going ahead, every time I go and ask you that, hey, find the time complexity, what are you going to find me? You are going to find me the worst case time complexity. In the interview will ask you, what is the time complexity? By default, it is the worst case time complexity itself. And the big O notation, the big O notation that we have heard so far will be used to solve it. So far, for all the iterative codes or all the loop based codes, we are strong enough to find the time complexity of any question which has a loop based syntax. Now there is another concept called the recursion, which I will talk about in the next video, which we have not talked about. So once we understand recursion, we will also understand that how the time complexity in the recursive code is identified. But for now, I think we are good enough. Any kind of code which is iterative in the nature, which involves loop on this earth, we are all set to find the worst case or the big O time complexity of that problem. Now, since we have understood time complexity, let's talk about the another important algorithmic analysis concept, which is called as space complexity. What is space complexity? So, sometimes what happens is, uh, if I have to go and solve a particular problem, right? And in order to solve this problem, if I use some additional space to solve it, that typically is called as a space complexity. For example, if I take a real world example itself, let's say that I have to go and do the cleaning of my house. I don't have enough money. So what I'll do, I'll try to clean my house myself. I'll pour the water, I'll use the proper disinfectant, and I'll make sure that my house is clean. So when I go and clean the house myself, where I didn't take help of anyone else, typically I'll go and say that, okay, I didn't use any additional resource to do it, so my space complexity is constant. On the other hand, if I go and feel that, okay, hey, you know what, that's pretty heavy, I can also afford it, so maybe I go and call the urban company people to come and clean my house. So when I go and call someone external to come my house and solve the problem of cleaning, that typically I go and make use of external people. So here I'll say that I have some additional space complexity. So space complexity is similar to the time complexity. I say that how the additional space complexity, additional space needed proportional to input size. So space complexity is nothing but how you need an additional space proportional to the input size. I go and say that the space complexity is defined like this. In the case if my problem or my solution does not require any additional space, I go and say that my space complexity is constant, which I go and represent like O of 1. If my space requirement is growing with the growing size of the input linearly, I go and say that the time space complexity is order of n. In the case I feel that my space requirement is growing at the power of 2 of the input size, I'll go and say that my space complexity is order of n square, like this, at Cooper. Fair enough. Let's try to see with the help of few examples. So if I try to move on and talk here, right, typically that why space complexity, why space complexity. Pretty simple. I know that today almost every company, when you go and deal with the data, you are just trying to solve the two problems, problem of storage and problem of computation. Even for the computation, you need some kind of space because you have to deal with the huge amount of data. So if an algorithm is not optimized on the space, you will end up wasting a lot of resources. So if you have to reduce down the cost, if you have to ensure that in the minimal space, I'm able to still do the computation and the storage, the space complexity has to be low. And that's why it's one of the important concepts that you have to keep in mind when you're designing your algorithm, you're writing the code in the industry, or you are in an interview and people ask you about the space complexity. So what is space complexity? How do we calculate? Let's try to see with the help of few examples. So let's talk about the first example itself here. So if I see here, it is a is prime. Basically, it is trying to see that if n is a prime number or not. Now in this entire algorithm, if I go and see n is my input size, and everything else that I have defined, for example, this variable and all this stuff, they all takes a constant space. Nothing in this takes space more than or which varies with the input size. So whether n value is 10 or n value is 2000 or n value is 2 million, the size or the space that it requires to do this computation remains the same. So in this case, I'll go and say that boss, my space complexity is constant, big O of 1. This is the constant space complexity, right? In this case, I will be having a constant space complexity. Let's try to move on. Now, in this case, if you try to see the code here, this is my input array, and I'm trying to just reverse the array, right? I'm just trying to reverse the array. But for reversing the array, I have used some additional space array. And size of this additional array depends on the input array. If the input array has a size of 5, this reversed new array that I have defined should also have a size of 5. The input array has a size of 1 million, this reversed array should also have a size of 1 million. The input array has a size of 1 billion, this reversed array should also have a size of 1 billion. Right? So since in this problem the extra size or extra space that I am doing is proportional to input size, so in this case the space complexity will be order of n. So in this case my space complexity will be equals to order of n. Fair enough? Cool. Let's try to move to the next question. Now I want you guys to try this question yourself first, and just pause this video, do that in your notebook, and then come back and tell me what your answer is coming here. So if I see here, the input size is this A, and there's another, so these are two input, these are the input, right? And let's say there's size n. Now what we do is that here I have defined a result which is an array, and then inside this I'm putting this another array. So basically result, if I go and see, is a two-dimensional array. And what is the size of this? The size of this is n into n. So for a given input size n, I am using what? I am using a extra space of the size n square. If the input size is 3, the size of my matrix or two-dimensional array that I will be, it will be 2 into 2. So here the space complexity, in this case the space complexity will turn out to be order of n squared. Here the space complexity will turn out to be order of n squared. This will be the space complexity. Let's move further. In this case, what we do is we have an input size, and for this input what we do, we go and this is an array, and inside this we put another array, right? So it's again a size of n. Now if you see here, this will run for n times, and this will also run for n time, right? So this array will be added for the n time itself, right? So again here, because of this, my space complexity will be equals to order of n square, because that's the extra space that will be needed. If I try to move on further and see here, so this is pairs, and inside this again I'm trying to push it, but this is running for n time and this is running for the root n time. If you're not able to identify why I'm saying root n time, you have to go back, watch the video again. So typically the size of the extra space which will be needed is n root n. So the space complexity here will be order of n square root of n, right? That's how the space complexity will look like. So this is how typically, sir, we go and find the space complexity in the iterative solutions. Till here we have been able to comprehensively cover what data structure is, why it's so important today for you to master data structures and algorithm, and that too in the language which is more relevant to you. So this entire course is primarily for those people who's trying to make it big in the field of full stack development, in the field of JavaScript stack. Post that, we talked about that how the algorithms are analyzed, what is the importance of time, and why we should not only talk about the time. We talked about the time complexity, we talked about how to find the time complexity in the linear algorithms, and also we saw the space complexity. So we are all set now. In the next video, we get started with the recursion, which is again the concept 0. Just like time complexity, recursion is the concept 0, which is needed for solving great questions ahead. If you're liking this series, The only thing which I expect from you people is little love. Sow that love on the YouTube. Share with your friends. Invite more and more people to watch these videos. Tag me on LinkedIn and Instagram that how is it going. Thank you.